It's a function you couldn't do with normal fuses.
Yes.
It's just not possible. That's why we see this on the rise. I think it's more having the ability to have one box that controls different current levels,
Yeah.
and you can software define what you plug into it.
Yeah. Yeah.
Instead of having to switch hardware to have a different current level.
Hello IPXers, we are at Electronica 2024 for another one of our updates. Remember, we go where you can't go, so we find the technology that you can't see, so we report it back to you. Now, this is Simon from Vishay. He's going to talk to us about EV and power. So, Simon, tell us about what you're doing for EVs with your power distribution.
Yeah, in Vishay we started to create more and more reference designs to get our design engineers kick-started into new developments, basically. What we have here is a set of e-fuses which is combined into a power distribution unit. Power distribution units and e-fuses in EVs are starting to exchange melting fuses or normal fuses which just blow, and then you need to come in to get it replaced. But here we can measure the current that goes through your device or to your end unit, measure the current and decide in software when to switch it off. So we have a very versatile way to set the overcurrent limit, and we use our new silicon carbide products to get a high efficiency even if we replace a normal fuse with silicon carbide switches.
Right. So let's just backtrack a moment. Let's just start at the beginning. Let's say these didn't exist.
Yes.
You haven't come along yet, and there's there's people designing EVs and they're trying to manage the power within there. What would they be doing today if this didn't exist? What would be their setup? What would they see as being the normal? What would they be dealing with?
Yes. So what you normally start with is a normal fuse panel and a set of relays. So you can switch on and off a certain OVC, your heat pump or whatever. And yeah, if you get overcurrent, your fuse won't blow. In a normal fuse panel.
Right. So, and do they just accept that as being part of life? They just see that that's how that works and that's just the norm? Or do they have other ways of solving that problem?
So we see EV manufacturers moving to this set of e-fuses.
Right.
For example, for software-defined vehicles, there is no way to program a normal thermal fuse. It's a piece of metal that blows.
When
it gets too hot. So you cannot configure it, but with such an approach, you are able to configure something. And then we have one channel which is intended to be bidirectional, to, for example, connect an onboard charger where you need current flow in both directions. Heat pump normally just draws power, your PTC heater just draws power, so we don't need to break current in the other direction since there is no source behind it. And what we do is we take this as a demonstrator here on Electronica to show how you could put something in a car in a nice box which is designed the way you would design it in a car. We test it for vibrations, we test it for cleavage and clearance. So this is how it could be in a car. But for designers, we offer these reference design boards, which is just a single channel. So you don't need to buy the whole thing.
So if you want to try and understand how you're actually solving the problem, you can go and get one of these and actually start playing with it and understanding the job that it actually does.
We'll be able to have them through distribution. They will be probably listed end of the year on Vishay.com. And going into normal distribution. Your normal distribution channel should have them. Instead of buying like a whole board, you could have this board, the small one, just one channel, and you can put in your own electronics to control it on this one connector, and we deliver the power part, the power stage, so you can start to play with this technology.
So what is the interface for that? How does that actually, do they plug that into their system that they already have, or what's the process by which they do that?
Yeah, so the intention is to Vishay as a manufacturer is just delivering power components. We are mostly passives and active, but we don't have that many ICs. So what you would do is you would connect to a set of gate drivers in this case. You would measure current, so an isolation amplifier if you want to have an analog input, a sigma delta ADC, if you want to have a digital input. It depends on how you want to control it and how you want to tie it into your system. We are looking at the power part mostly. So you have access to the gate of the pre-charge circuit. So you can pre-charge your appliance, your DC capacitor, DC link capacitor in, for example, your heat pump. So you can switch on the pre-charge path. You can measure the current and see either it's a voltage measurement here, which goes with analog signals onto this connector, and then you have the pre-charge where you have the gate and analog signals from your current sense resistor. So you can decide how you want to do it.
You've put a lot of flexibility in there, and you've got a lot of what different ways that you can look at the problem and understand it and analyze it.
Yes. So
you're giving people a lot of options there.
We are trying to make it easy to have the power stage. And to start to develop, you can download the schematics and then print your own board if you want. But we are looking at the power stage more than the control logic. Within the next year, we will populate this board with an FPGA, and we will be looking very closely on how to detect the current rise, the di by dt, and to detect it in a time frame, let's say 5 microseconds or something. Like a very quick response time is what you would normally want to see in such an eFIX application. But doing it with normal current sensing technologies is not that easy.
No. So one last question. There's two ends to the EV market that I see at the moment. Obviously, there's the cars themselves, which are becoming, more looking like the cars that we're all used to. But there's two ends of that. There's one, the actual how far they can go, so the amount of power that they're using in terms of how far they go, but also the amount of electronics that are in them, which is constantly going up.
Yes.
So in terms of how is this going to those two things are not going to change. They're going to keep going vertically up. So I imagine that kind of thing is going to become more and more important as we go into future generations of cars.
Yeah, I see it in the terms of smartness, software-defined vehicle.
Yes.
It's a function you couldn't do with normal fuses.
Yes.
It's just not possible.
Yes, that's the question I'm asking. Yeah.
That's why we see this on the rise. I think it's more having the ability to have one box that controls different current levels.
Yeah.
And you can software define what you plug into it.
Yeah.
Instead of having to switch hardware to have a different current level.
Yeah. So what you're actually saying is, if your car is going to be using more literal electronics, using more software, doing more complicated things, there's no question you're going to need something like this.
I think that's the way.
Well, you're bound to think that because you're from Vishay. But yes, but just in general, this is a direction that design engineers have got to go in.
If they want to be flexible,
yes. If they want to be flexible,
and if they want to reduce wire sizes, yes.
Yeah. Well, I think they're all trying to do that.
If they want to do the cheapest solution that is unflexible, they don't have to.
Yeah. No. Well, they're not going to be doing that. Things don't go backwards.
But you see the same, not just in EVs. You see it in normal distribution panels in your household.
Yeah.
You see the first smart fuses, or however you want to call them, eFuse, smart fuse.
Yeah.
Software definable fuse, resettable fuse.
Yeah, absolutely.
There are so many names to it. This notion of being able to control it from afar, switching off like a certain appliance. It's a switch. You can control it as a switch as well. It's not just a fuse. So there are many more functions to it you gain by going this way.
There we go. Thanks, Simon.
Thank you.
Good job.
Thanks.